Hey guys, and welcome to a new week of Sliceform, where this week we are going to be talking about joints. Now, as stated before, joints are connections between two components, not bodies, that can be joined in different ways and have different degrees of rotation, whether they're sliding joints, rotating joints. There's lots and lots of different types, and we're going to be going over all of them today. Now, we've gone over rigid joints in the past a lot, where if you have one component that's fully grounded and you have another component that has a rigid connection, both of them are fully locked together and they will not move. A good example would be a bolt and a nut being firmly put together. But there's lots and lots of other joints that we haven't touched on yet. The ones we'll be working on this week are called Revolute Joints. These are where we can actually have a degree of rotation with it, whether it be a wheel, a gear, or essentially anything that can spin in place. Now, in our previous class, we did go over the slider joints in our fire piston class, where you can have two components that can be pushed in and out of each other. But we can also extend that idea with something called a cylindrical joint, where we can actually add a degree of rotation to this. Some cylindrical joints can be found in certain piston systems, but they can also be found in basically any real-life object where it can move linearly and have a rotation. A pen cap is a really great example of that. Some other joints that you may find in other mechanical systems may be something like a pin slot joint. This is where you can have a degree of rotation and linear movement that aren't shared in the same axis. Something like a rack and pinion gear system is a really great example of that. We've gone over planar joints in the past, where you can simply move a part along a 2D axis, but you can also push this by going into a ball joint, where you can give it 3 degrees of rotation. Something like a ball joint on the top of certain camera equipment is a really great example of that as well. In this class, we are going to be going over different types of rigid joints and revolute joints, and we're going to be designing this as if we were going to be making it in real life. Now, fundamentally, joints are made between two different components, and in Fusion360, we need to decide whether we are using internal or external joints. It is purely personal preference which one you choose, but I find that external components work a little bit better with how my mind works and how I design things in CAD. If you have any experience with other types of CAD softwares like NX or SolidWorks, you may also find that other external components just work a little bit better with you. Because of that, we are going to be going up to our data panel in the top left corner, and we are going to be making a new folder called Pizza Cutter. This is where we can house our assembly file and all of our small components that make up our project for today. We're going to start off by closing our data panel and then saving this file as our 000 assembly file, so that title always pops up to the top of the list, and we can go ahead and click save. Because this is a metalworking project, we're going to go up to our document settings and expand that and double check that yes, our units are in inches. And then we can start off by making a brand new component. This one is going to be an external, and we are going to be naming this end cap. So we'll start off by making a new sketch on the front plane. This front sketch is going to be a little strange because we're going to have a threaded section to a bolt, but also a nice domed smooth end to it. Using our 3-point tool, we're going to be starting off from the origin and going up and to the right, and then just making a general arc. It doesn't need to be anything special. And then using our line tool, we're going to be going from the end point completely horizontally, then down, over to the right, down, and then back to our origin. We also want to be putting a line from the origin all the way vertically going upwards, and this is going to be a construction line. And the reason we have this is because we want the end of our bolt to be totally domed, just aesthetically. And to do that, we need to be making that curve tangent to that line, so we don't have a strange bumpy corner on this end when we end up revolving it. So we can just hit escape. For all the dimensions on this, they are all going to be 1/8 of an inch and 1/2 inch. So we can say the distance from the 2 endpoints of our curve, that is 1/8 of an inch. The section of this flat point above, that is also going to be 1/8 of an inch. The threaded end of our bolt right here is going to be a 1/4-20 bolt, which means this radius has to also be 1/8 of an inch. And if we move this up, it'll be a little bit more realistic to what the end product will be. We can also set the diameter to be 1 inch, which would mean the radius would have to be 0.5 inches. Conveniently, this is also the length of our threaded section as well, 1/2 inch. There we go. We can just go ahead and finish this sketch and then revolve that profile about that bottom horizontal line. There we go. And when we click OK, you can see what that domed head kind of looks like. That's why we had the tangent line to the construction line. And we can finish this part by adding a 1/4-20 thread to that curved face. Obviously, we want this to be modeled. And because it already is a 1/4 inch diameter, it's going to give us a 1/4-20 thread. So just like with all of our machined threads, we also want to put a little light chamfer on there. So you can make a brand new sketch on the front plane, and we're going to just be using our line tool to make a little right triangle. Again, we want to have this be a 45-degree angle, so we can just make the 2 edge lines totally equal. And this one wants to be 0.04 inches, which is about 1 millimeter. This also wants to be lining up with the edge of our thread as good as we can. So we can just say that the distance from the top of the triangle to the origin is that 0.25, or 0.125, excuse me. That would be the 1/8 inch radius. We can also hit escape to get rid of the dimension tool and click P for project, so we can click on the edge of the bolt. And then using our collinear tool, we can line up these 2 lines and fully define that triangle. We can finish the sketch, and then we can be making a revolve cut with this piece. As you can see, my red axis, I can just barely click it, but it'll be a little annoying to click it. So we can always go into our browser and expand the origin, and then click the X axis, and then hit OK to revolve that cut. That looks great. Now, because this project is going to be a pizza cutter, it's going to be around food, we need to make sure that all of our materials are hygienic material. And when you're talking about hygienic metalworking, you'll usually always go to stainless steel. This is a different type of steel, it's a different alloy, it's strangely not magnetic, but it's very, very dense, and you'll find it all the time in different cooking objects. So we can just add an appearance of a brushed stainless steel, that always looks kind of cool. So let's click A for appearance, and then in our search library, we can just look up brushed, and we can click and drag this stainless steel onto it, and you can see all of the different striations from the brushed steel. So with this component all done, we can go ahead and click Finish the Edit in Place window, and then we can go ahead and save this file as well. And as soon as we do this and go back into our data panel, you can see that our end cap is now in there as its own individual component. But now, with our top file totally activated, we're also going to be adding on a new external component, and this one is going to be called the inner body. This is going to be the inner tang that connects the different parts of the handle. It's going to add a lot of rigidity to our part as well. And we can just click OK for that. And with us being in the Edit in Place window, we can also make our sketch directly onto this part as well. Because this component is going to be revolved around the same axis as our end cap, we're just going to be making a brand new sketch on the front plane, and we can be clicking P for project and selecting the very underside of the bolt so we can have some geometry snap to this. We're going to be clicking R for rectangle, and we're going to be drawing a very simple rectangle where the left-hand vertical line is going to be collinear to that projected line. And we're going to have a coincident relationship between the bottom horizontal line and the origin. And we can just dimension this rectangle to be 4 inches long, and then 0.25 inches tall. After we revolve this, this is going to give us a 1/2 inch diameter stock. We can go ahead and finish this sketch and then revolve that profile, again, about that bottom axis, and click OK. And because this is a fairly limited amount of options that we have when we're in the Edit in Place window, we're just going to be finishing this, saving that part, and then when we go back into our data panel, you can see that our inner body is right there, and when we double click it, this component is going to be opening up as its own standalone project in its own window. We'll be knocking down some of these harsh corners by adding a chamfer to each end of this rod, and those are going to be 0.02 inches. To have something for our end cap to screw into, we're going to be adding a threaded chamfered hole on this end. And we can do this by clicking H for hole and then selecting that place. And we can click and drag this little blue dot where it will snap to the very, very center of this. And if we go back to our dialog box over here, we want this to be a countersunk tapped simple hole. We're going to be making the very top diameter of our chamfer just a little bit larger than our threaded hole. So this is going to be 0.25 inches. The depth of our hole is going to be 5/8 of an inch, or 0.625. And then the threaded hole that we have, this is not going to be a 1024, even though that's a very common size. This is going to be a 1/4 20 thread. And we do want this to be a model thread, and click OK. So we do want to have this threaded section on the exact same thing on the back end. And we could do the exact same hole operation if we want to, or we could make a mirrored effect, which would be a little bit more efficient, because now instead of changing two different threads, two different holes, if we ever need to change it for the future, we only need to change one. But unfortunately, if we expand our origins from our browser, you can see all the planes that we have are not connected, or they're not in the middle of our piece, which means we have to make a new construction plane. And we can use the mid plane and click the two ends of our piece, and this will add a construction plane exactly to the middle for us. So if you forget exactly how long this beam is, no problem, it'll just put it right in the middle. We can finish off this construction plane by clicking OK, and then using our mirror tool, and instead of having our faces, we're going to change this to features and make our hole the feature that we want to mirror. And the mirror plane, as you guessed it, is this little construction plane right in the middle. You can see a little preview of it on the other side, and then we can just click OK, and you'll see our thread is popped up. And we really don't need this construction plane anymore, so we can just get rid of that in the browser. Again, we do want to give this a stainless steel appearance, and it's already in this design window, so we can just click and drag that onto our part, and then hit close, and we're going to be saving this part, which will now update the assembly file. Back in our assembly file, we can just go and update our components, and it is now updated and in the correct location. Our next component is going to be the wooden handle that goes over this shank, so we can just click New Component, verify it is external, and then rename it as that wooden handle. Now the entirety of the geometry for this wooden handle can actually be made in this Edit in Place window. Again, we're going to be making a revolved part, so we can just make a new sketch on the front plane. And then just like the last component, we are going to be clicking P for project and selecting the underside of the bolt and then the outer surface of our little shank in the middle. And by clicking OK, we have now got the end point that we can grab to, which would represent the outer surface of our piece. Now, using our line tool, we are going to be making a line that starts from the underside of the head. This is going to be a 4-inch long line, and we want this to be coincident with the very top surface, that little point right there. That should make it fully defined and black. Then we can use our line tool again, start from the end of that line, go upwards to this point so everything can be nice and flush, and then another line going out, and this is going to be 1/4 of an inch. Now we're going to be modeling in 3 different finger grips on there, and that's kind of screaming to put a 3-point arc on this end. To dimension this is going to be a 1-inch long distance between the arcs. Our 2 points do want to have a horizontal constraint to them, and then the radius of this arc wants to be 1.5 inches, which will be just a nice little subtle swoop. And we want to have 3 of these, and this is a small amount of patterns that if you really wanted to, you could just go ahead and make all of these, or you could go ahead and add in a rectangular pattern to these. Really doesn't matter. I'm just going to be using the rectangular pattern, pulling these out. I only need 3 going along the x-axis. I do not need any along the vertical axis, so we can keep that as 1. My distance type, I do want to change this to spacing, because I know the spacing has to be 1 inch plus that 1/4 inch, so all of them line up nice and neatly. We can finish this by clicking OK, And then to finish this off on this end, to actually join it to make an entire profile, with our line tool, we can come out that 1/4 inch and then finish it off by going down to that final 4-inch section. Now, as you can see, it's this nice little sky blue, which means it's a fully conclosed profile. And we can finish this sketch and then revolve this about that red x-axis and then click OK. Now, these finger grips are a little bit sharp. We've got 6 edges that are just a little bit too pointy. So I'm going to go ahead and add in a fillet. I'm going to click these 3 faces and give it a 1/4 inch radius to it. There we go. That's relatively easy to do on a wood lathe, which is where we would make this. Speaking of, let's add a wood finish to this. So I'm going to click A for appearance and then go down into my wood section. And mahogany usually looks pretty good. We can click this over and then we can kind of mess around with the scale a little bit just by double clicking on mahogany and then moving our slider. And there we go. That looks pretty good. And that'll be this component fully done. So we can just hit finish edit in place and then save this component. Now, as this is the joint class, you may have noticed that none of our parts are grounded, so they can all kind of move around in our workspace, which we don't want. So we can first off ground our end cap just by right-clicking its name in the browser and then hitting ground. And then for the rest of our 2 components, now they are in the correct location, so if we wanted to, we could add in an as-built joint to it, which we will do. So you can click the tool and then click the end cap, let's say the wooden handle. It's always going to be set to rigid as the first one, that's the most common, and then click OK. And we also want to do the same thing with our little tang right in the middle. So we can click an as-built joint, select our wooden handle because that is now affixed to our end cap, and then clicking the inner body, and then hitting OK. Now if we try and click and drag any of our components, we can't because they are all locked in place. Now our next component is going to be something called a bracket, which will extend from our handle outwards, which is where we're going to be housing our little blade. We can just do this by verifying that our top component is activated. I really cannot emphasize just how important this step is. I've done this project way too many times where I've accidentally still had one of my components still fully selected, fully activated, and then as soon as I try to add a new component, all of these individual components now become its own assembly file. So really always double check to make sure that is always activated. We can make our new component called brackets, and because this is going to be having some more geometry that actually inserts into the female end of this thread, I actually don't want to be making this in the edit in place window. I actually want to be saving this as its own separate file and then going into my data panel and then opening it up as its own separate file, as its own separate blank workspace essentially. We can close that down. We also don't need that inner body anymore. We can close that down as well, and we just be starting off with a new sketch on the front plane. Now for this sketch, we can just be using our line tool, starting off from the origin, making a male threaded section, then going up. This will end up being the exact same height as our end cap, so everything stays nice and flat. Moving over, then switching to a 3-point arc. Again, we'll be using similar dimensions for this little domed headedness that we had for our end cap, so there's some kind of visual symmetry going on. Then going back to our line tool, we can touch off from our 3-point arc, go over to the right, and then have another domed head with our 3-point arc as well. And then because we need to make our bottom axis, we're going to be using our line tool again, grabbing from the end of our 3-point arc and our origin. Now we can add in all of our constraints. Now, if we move over to the very end of this project, you can see luckily we already have a tangent relationship between our arc and our line over here, but we want this to be a totally, almost like a hemisphere when we revolve this. So that means that we want to have a coincident relationship between the center of this arc and this line. So now the only thing we need to do to change this would be to set its diameter, essentially. But now we can go ahead and add in all of our sketch dimensions. Now with all of our dimensions fully completed, the last thing to do is make sure that the center of this arc is completely coincident with our bottom horizontal line. That will make sure everything in our sketch is fully defined. So we can finish this sketch and then revolve our two profiles about that bottom horizontal line, and then click OK. Now, just like before, this threaded end does need to have an actual thread on it. So we can select this face, say modeled, and yep, it's already set it to 1/4-20. That makes our life so much easier. And then we also want to knock off the corner over here. So let's make a new sketch on that front plane, make our little classic triangle. Remember, they always want to have equal sides, which will make this angle 45 degrees. We want to dimension this triangle to be 0.04 inches, that's about 1 millimeter. We can make this vertical line of our triangle and the origin totally coincident, which will add a vertical constraint to it. And then we also want to dimension the top point and the origin to be that 1/8 inch, which will give us a 1/4 inch rotation when we go into our revolve tool and then revolve it about our red x-axis and click OK. We can also add on our brushed stainless steel appearance to it. Click and drag that onto there, fantastic. And then we need to have a little cutout section right there. So we're going to be making a new sketch, this time on the top plane. And this one is going to be a little funky because we aren't just making a little cutout that goes directly through the middle. We want it to be slightly higher. And that's because when we put our pizza cutting blade through the middle, we want the center of the blade to be exactly running down the middle. Because we know the thickness of our blade, we can say exactly how much above that line it needs to be. So we can click P for project and select this left horizontal line, and we can make those two lines perfectly collinear. We can dimension this line to be about 2 inches, as long as it's just outside of this domed arc. Either way, that's fine. And then we want this this top horizontal line to be 0.03 inches above. We really don't care about exactly how long is this, as long as it's just longer or just outside the bounds of this part. Then we can hit Finish Sketch and then have this be a double-sided extrusion. So for the direction, we can just make this symmetric and then click and drag this above so we know that it's cutting all the way through. Just like with all of other extrusions, there's lots and lots of different ways to say this. We could have, still have this be two-sided and just say exactly what is the height of this. We could set our distance to all or through the surface. Many, many different ways to do this, but as long as you get the correct final end goal of this project, it really doesn't matter. So we can finish this off. Now at this end point, we are going to have a very small shouldered bolt cut through. So we need to have a little threaded hole. So again, we're going to be clicking H for hole, selecting this surface, and then moving over this little blue dot so it snaps to the center of that arc. Perfect. This is going to be very, very similar to the other ones, or the one that we made previously. We do want to have a very light chamfer on the end of it, just so it's a little easier to have that bolt slide in. This is still going to be a 1/4-20 bolt, and we really don't care about the depth because it is a cutting operation. As long as it cuts all the way through, that's all we really care about. So you can click OK to finish that off. And like before, we do have some kind of sharp corners on there. Chamfers are nice, but let's put in a nice little fillet. So you can just select that face, and this is going to be 0.02 inches, just like we had with the rest of our chamfers on our part. And then anywhere that actually meets, so this sharp corner there, we also want to be adding in a little fillet on that as well. If you're ever having trouble wanting to, well, make a first chamfer and then add more and more and more chamfers or fillets, and you're going, hey, why isn't this clicking? It's because we need to hold down Control and then select the line and then release. And this will add in a nice fillet over everything. And then click OK. Now that this component is done, we can go ahead and save this part and then go back into our assembly and then update this file because it's currently out of date. Now that our assembly file is fully updated, you can see our component is there, but it's actually inside the piece. So we'll just click and drag that out. And we do want to be adding in a rigid joint between the two. But as you can see, we can't use the as-built joint because they're not already in the right location. So we need to hit J for joint and use more of a traditional joint. And this is where we can kind of go into a lot of the confusion where joints come in. People go, I don't know what faces to click, what edges to click, what any of this rotation means. So this is where we can go into it. We have two components in our joint dialog box up here. The snapping is going to be what edge or what surface or what vertex is going to be having our joint icon. Now, our joint icon is a really thin circle. It's like a disc. And when you select the two discs on two components, those two are going to be meeting. If you have one component and another one that's like this, then those two discs are going to be moving to making sure they're completely touching. So anytime we have a snap, we can technically put it on any of this surface, but we want it to be at the very center of this circle. So you can click on any edge that will put that little joint icon right in the center of that circle. Then the other component over here, we can do a similar thing. I know I want to have this face fully pushed up against that surface over there, and I want to have the center of the center of my circle snapped on there. So when it moves over, those two joint icons are totally in the same area. They are coincident, is a much better way to think about it. We can also kind of check out our joint alignment over here. So if we want to move it in the X, Y, or Z location, we can always click and drag these arrows where it's saying, yeah, those two joints are in the right location, but they're now eccentric by a certain degree. You can also change the angle. You can also flip it. So if you accidentally make the joints that are in the same direction, but when they flip around, they're now going through each other, you can just flip it around. The joint icons are still technically in the same location, but they're just facing the wrong way. So we can just click OK to get rid of that, and now we have a rigid joint over all of our components. Now our next component is going to be what's called the shouldered bolt. We'll go over what a shoulder is in a little bit, but what you'll want to notice is that this bolt is going to be screwing into this threaded hole that we just made, and there's no planes that kind of cut through this. So if I was going to make this in the edit in place window, it would be really, really tricky. This is a great scenario where saving it and then working on it as its own separate location is actually a much better idea. That's exactly what we're going to do. We're going to be making a brand new component. This one is going to be called a shoulder bolt. Clicking OK, and then before doing anything else, saying finish the edit in place and saving this part. Going back into our data panel and then opening up the shoulder bolt as its own file. So to make this part, we're going to be making a brand new sketch on the front plane. And very simply with our line tool, we're going to be starting from the origin and making just a few steps. And then going back down to our x-axis and then finishing off our location. Then we can be adding in all of our sketch dimensions. So now with this sketch fully completed, we can go ahead and finish that and then revolve this about the bottom line. Now we can kind of go into what a shoulder is. So this main cylinder that we have on top, we can be cutting in a little flat section so we can have a screwdriver to screw it in. This smaller cylinder on the bottom, this is going to be our threaded hole that will go into our bracket. But then we have this little step right here. This is going to be, well, it's going to have no geometry on it whatsoever. It's just going to be a perfectly normal smooth cylinder. But this is where our blade is going to be running on there. If we go back into our sketch, you'll see that this is a really strange dimension, 0.06. It isn't a normal number, but that is just barely larger than the sheet material that we're going to be using to make our blade. And so we do have just a little bit of wiggle room, so it's not totally compressed. Our blade can move back and forth just a small amount, and it's able to rotate freely. So going back to this, let's add a thread to that bottom cylinder. Again, this is going to be a 1/4-20 bolt. And just like we've done in the past, if you guys want to make a 0.04 inches revolved cut just to clean up the end of that threaded section, and then we can add our little cut in the back. So we'll be making a new sketch on the back of our bolt, And this one is going to be a center rectangle tool. We're just going to be making a very simple rectangle that we can have a flathead screwdriver go into. This is a really easy operation to make on well, a hobbyist machinist setup. Making a Phillips head is very, very tricky. So the height of our rectangle is going to be 0.08 inches. That's just big enough to put a flathead screwdriver into. And then we're going to be projecting the outer circle of our head so we can add a tangent relationship between it and that vertical line. And then finish the sketch. So we want to extrude cut this profile into our bolt, and this wants to go in negative 0.16 of an inch. And then because we still have all these sharp corners, let's go ahead and add in some chamfers to this. We don't need anything too heavy, so let's maybe make this 0.01 inches, something not too heavy. And then we can also click any of the curved faces that we have on here, and anytime you have an edge that meets to this face, it will just add a little chamfer to this. That looks perfect. We can also add on a brushed stainless steel appearance to this. There we go, and then save this part. And then we want to go back into our assembly and then update this file. As you can expect, it is in the wrong location, so we'll just bring it a little bit closer to where it needs to be. And then we can add a joint. And remember, we always want to have those two joint icons basically in the same area. So we want to have not this outer face, but the shoulder to be touching the threaded hole that we have. There we go. It's already in the right orientation, so we didn't need to spin it or rotate it. It's already in place. And our last component that we're going to be making is our blade. This is the really exciting one. Again, this is going to be a normal external component, but we're going to be making it in its own file. So finish that edit in place, save the part, and then open it up as its new tab. This is very simply just going to be a revolved blade, so we can make another sketch on the front plane, and with our line tool we can basically make a vertical line that goes off at an angle, comes back down, and then completes it. We do want to have a distance between the underside of this horizontal line and our origin, because we're going to be making a hole within our revolution that will then fit over our shouldered bolt. Now for all of our constraints, we do want to have these two angled lines be totally equal, so they will point right in the middle. And then we want to have a coincident relationship between the left vertical line and the origin. And for our dimensions, we can add in a couple that are very easy to remember. So the hole, or the hole's radius, is going to be 0.2 inches. That will fit over the shouldered section of our bolt that we made. And also the thickness of our blade. This is going to be 0.05. Now that number is interesting because conveniently that is the exact same number as stainless steel gauged metal. Anytime you are buying a bit of sheet metal, it's going to have a certain number, a gauge, which correlates to the thickness. Now this gauge number changes based on what type of metal you have. So if you have 28 gauge steel, that's going to be a different thickness to 28 gauge aluminum. Same thing for stainless steel. So this is a nice neat number that is only 10 thou smaller than the shouldered bolt. And so it still has just a little bit of wobble, but not so much that it'll flex and kind of break out of the way. Our total radius for our piece is going to be 1.375. And then the length of the blade, this is going to be 0.4 inches. And as you can see, our blades can still move side to side, which means we need to have that top point be vertically aligned to the midpoint of this bottom line right here. So with our point tool, we can move it over till we see that little midpoint, constraint right there, and then add a horizontal connection between the very tip of the blade and then that middle point. And then that means it is fully defined. We'll finish this sketch and revolve it around our x-axis for like the 1,000th time today. Hit OK, let's add on our brushed stainless steel appearance to it, that always looks so good. And then we will save this part and then bring it back into the assembly file and update it. Again, this isn't in the right location, so we'll just bring it out And now we can add in our Revolute joint. So for the time being, all of our other components that we have here, they need to be fully locked in place. But for a pizza cutter, if all the pizza locks in place, that's a terrible pizza cutter. We want to have this blade be able to spin, so we can add in a Revolute joint. So we'll go back into our joint tool, but then there's a little pop-up right here. We're going to change this from rigid to Revolute. Revolute basically just means revolve. Then we can go in between our two components and say, okay, well, which side do we want to be moved over? And we can say, yeah, our snapping point is going to be this side of the blade. And then moving over to our shouldered bolt, we want it to be lined up with that edge right there. When we do this, there we go, it's already giving us a little spinning animation. Very cool. But as we go to our right, you'll see that it is fully touching this edge, but we've got a little bit of a gap right there. And we do have a 0.010 of an inch gap on there, which means we can move this over -0.005 so that it's fully directly in the middle, and then click OK. And there we have it, guys. We have got a 100% CAD made pizza cutter with a revolving wheel. Fantastic. Now go ahead and make some pizza.